Richard Dawkins, The Magic of Reality, How We Know What's Really True. Prepare to embark on a journey that reveals the truth behind the origins of the universe and the beauty of reality, as seen through the lens of science. In The Magic of Reality, Richard Dawkins unravels the seemingly supernatural occurrences and explains them in a clear and engaging manner, making the complex world of science accessible and engaging. Discover how scientific instruments, models, and understanding of the natural world bring clarity to the past and present, while also unveiling the very building blocks of life, atoms. Learn about evolution, the interconnectedness of species, and how the sun's rays are vital to life on Earth.
Sensing the universe. Our perception of reality is based on our senses and scientific instruments. But what about the past? How can we know what happened before our time? Fossils provide us with indirect evidence of ancient creatures and their existence, reminding us of the importance of imagination and understanding in perceiving the universe. The power of scientific models. Scientists use models to better understand complex concepts beyond our immediate understanding. These models can be based on hunches or careful considerations and come in various forms. Their predictions are then tested through experiments to either refine or reject them. Theories and models are the heart of science. They enable us to make predictions based on complex concepts that are beyond our immediate understanding. Models can take different forms, such as computer simulations, wooden structures, or mathematical formulae, depending on what aspect of reality they're designed to explain. Scientific models are not merely guesses. They are the result of a combination of hunches, careful considerations, and observations. Scientists then use these models to make predictions and test the outcome of experiments, which they then use to either refine or reject their model. Gregor Mendel's model of genes is a classic example of this process. The 19th-century Austrian monk grew peas in great quantity and counted the number of smooth and wrinkled peas in each new generation of plants. Using this model, he made predictions about the number of smooth versus wrinkled peas in the next generation. When the crop confirmed his predictions, he knew his model of genes was right. Another example is Isaac Newton's discovery that regular white light consists of light in all colors. Newton passed light through a prism, creating a rainbow-like ray of colors. He passed the multicolored light through a lens to confirm that the colors were innate, and then through another prism to shatter it once more into a rainbow. This process allowed him to confirm that white light indeed contains all colors. Scientific models have transformed the world we live in, from quantum mechanics to relativity and genetics. They are indispensable tools for making predictions and testing theories. Through careful observation and experimentation, scientists continue to refine their models to better understand the mysteries of the universe. The Enchantment of Evolution. The process of evolution, similar to the fairy tale transformation of the frog into a prince, is explained through natural selection, the selection of the most favorable traits in an individual species. Darwin's concept of natural selection enables gradual changes in species over time, resulting in the evolution of simple animals into more complex ones. Genealogy illustrates the genetic lineage between species and highlights the gray areas within the evolutionary process. The interconnectedness of all living things. Our understanding of the relationships between living things comes from various sources, including fossil records and genetic analysis. By examining igneous rock and comparing gene expressions, scientists have determined the age of fossils, relatedness of species, and the fundamental kinship of all life. Radioactive isotopes in igneous rocks aid scientists in calculating ages of fossils. Comparing gene expressions across different animals reveals the degree of relatedness between them. Despite variations in DNA, all life on Earth shares a common ancestor and is thus fundamentally connected. The tiny world of atoms. Atoms are the smallest objects in the universe, and even solid objects are mostly empty space at the atomic level. There are 118 known elements, and molecules are formed by joining atoms. The properties of a molecule are determined by the number of atoms and their arrangement. The atoms consist of three subatomic particles, protons, electrons, and neutrons, each held by strong fundamental forces. Despite their tiny size, the atoms are held together due to the forces acting within them. The arrangement of carbon atoms gives rise to both diamond and graphite, and long chains of carbon atoms form the skeleton for complex molecules needed to build living organisms. Origins of the universe. The diversity of atoms originated in the stars through a process of fusion, supernovas, and gravitational force, eventually leading to the creation of our solar system. Everything in the universe, including us, is made up of atoms. But where did these atoms come from? The answer lies in the stars. All planetary bodies exert gravitational force on each other, causing stars like the Sun to become extremely hot under immense pressure. In this heat, pairs of hydrogen atoms fuse together to form helium, releasing heat and light in the process. Larger stars burn their hydrogen faster, causing them to explode in supernovas and creating heavy elements like lead and uranium. These elements are spread throughout the galaxy and eventually collect and combine to form new stars and planets. Scientists believe that our solar system was created from a giant cloud of celestial dust left over from a dying star. This beautiful and complex process of fusion, supernovas, and gravitational force has led to the creation of everything we know, including our planet and all its flora and fauna. We truly are made of stardust. The essential role of sunlight in life on Earth. Sunlight is the essential source of energy for all life on Earth. Through photosynthesis, plants utilize sunlight to transform water, minerals, and carbon dioxide into sugar, which herbivores consume to power their movement and survival. Carnivores then consume herbivores to build muscle and hunt, resulting in a decreasing transfer of energy. Despite this, small organisms like parasites, fungi, and bacteria that feed off dead animals continue the transfer of energy. Sunlight also powers renewable energy sources like solar and water power, which rely on the sun to heat water and create movement. Without the sun, all forms of life and energy would cease to exist on Earth. The spectrum of light. Light, like sound, can be thought of as vibrations of different wavelengths that traverse space. White light consists of different colors, and varying frequencies of light waves determine color. We can only see a limited amount of wavelengths on the spectrum of light, and ultraviolet light and extremely harmful X-rays and gamma rays are at the very high end of the spectrum. Infrared light, which we can only feel as heat, is at the other end of the spectrum. Each wave that makes up the light spectrum is useful in some way, such as microwaves and radio waves for communication, and X-rays for medical purposes and astronomy. Understanding the universe through the Doppler effect. The Doppler effect, a phenomenon that we hear when cars pass us, can help scientists understand the beginning of the universe. By analyzing the light emitted by stars through a spectroscope, mathematicians can identify the elements present and calculate our distance from them. By observing the changes in the barcode patterns of galaxies, which become redder as they speed away from us, astronomers can determine that all galaxies are moving away from each other. By calculating the speed and distance between galaxies, astronomers can estimate that the universe began around 13 to 14 billion years ago. The scientific inquiry using the Doppler effect shows how it can help us understand the universe's origin. The power of fantastic stories. Humans are natural storytellers who often exaggerate, leading to fantastic and memorable tales. Unique coincidences and unlikely events happen, embellished over time to remarkable paranormal stories. Forgetting the mundane and focusing on the fantastic is the reason behind our love for extraordinary stories. Decoding the Supernatural. Understanding the likelihood of miracles through alternative explanations and scientific progress. The existence of miracles has long been debated, with many people considering them supernatural or inexplicable occurrences. However, philosopher David Hume offers a way to analyze and understand these events by considering alternative explanations and selecting the most probable one. Hume's heuristic suggests that an event can only be considered a miracle if all other explanations are less likely, thereby qualifying only the most exceptional occurrences as miraculous. For instance, the story of Jesus' water-to-wine transformation offers several explanations, such as the rearrangement of components or a clever trick. Therefore, if an unlikely event has a possible explanation, it should not be considered a miracle. Moreover, the evolution of scientific knowledge has helped us to make sense of seemingly miraculous events from the past, such as earthquakes, which were once believed to be divine punishments. But with time and accumulation of knowledge, we now understand earthquakes to have entirely natural causes. In conclusion, while certain events may seem inexplicable, we should approach these with curiosity and skepticism, searching for evidence explaining natural causes. We should see such mysterious occurrences as an opportunity, a chance to challenge ourselves and refine our models closer to the truth. Hence, to decode supernatural phenomena, we need to observe and study alternative explanations while continually challenging ourselves to make complete sense of the world around us.
In conclusion, The Magic of Reality offers a fascinating glimpse into the world of scientific understanding, dismantling myths, and turning complex concepts into comprehensible knowledge for everyone. Dawkins demystifies seemingly supernatural events and shares the true wonders of the natural world, from the origin of atoms to the workings of evolution and the relationship among living beings. By offering an exciting window into topics ranging from the Doppler effect to photosynthesis, you are left with a richer, more profound perspective of our interconnected reality and an appreciation for the true magic of the natural world around us.